BIMStorm Capitals Alliance, Tshwane, South Africa, and Alexandria Federal Friendly Zones. Introductory webinar. We'd like to thank this webinar sponsor, the AEC ST Conference, happening in December in Washington, D.C., where we'll also be presenting the results of this BIMStorm. We'd also like to thank the other sponsors of these two BIMStorms. Please check the website for updates. The overall schedule is we're already starting in August in a virtual collaboration for both of these BIMStorms, and the actual live events will be in mid-September. Both events are back-to-back, and a lot of the material is being shared from one to the next, and we encourage all teams to participate in both. The jury review will be from September till October, and the awards will be at the AEC ST conference in Washington, D.C. in December. First, some basic concepts about how we're looking at BIM. BIM can be a complex model, but can also be simple requirements from a client saying how many square feet a building needs to be, what the programming area needs to be, and the basic arrangement of spaces, the blocking and stacking. It's important to have all these elements integrated in one continuous workflow to be able to demonstrate to both the owner and other interested organizations what the projects are going to look like. In the Boston BIMStorm for 90 minutes, we interacted with the audience members who submitted their projects through iPhones and also on paper and pencil the forms that were filled out and passed to the front of the room, and over 130 buildings were created in this 90-minute period during the presentation. The Onuma planning system is a model server that allows interaction with data in real time through the web, allowing different levels of users to interact, all the way from just using Excel or attaching comments, or other users being able to go into more levels of detail, all the way from the interior of a space to the urban planning scale, and then attaching attributes and comments to the models, both at the building level and at the room level and at the object level. Another very important concept is that we're using GIS, or Geographic Information System, standards to be able to locate multiple buildings and manage the local coordinate systems of BIM and the world coordinate systems of GIS, and to be able to look at buildings in the context of the BIMStorm with hundreds of different users involved. In the Los Angeles BIMStorm, we had a 24-hour BIMStorm process for 11 countries and over 130 players, created 420 buildings, 54 million square feet. We didn't print 2.8 million pages of documents, but that was the equivalent output, and it was 0 miles traveled. Everyone collaborated virtually. We did not assemble in one location. This is the result of the Los Angeles BIMStorm, viewed in Google Earth. Different users interacted, all the way from hand sketches to cost estimating to life cycle analysis to energy and mechanical systems being designed from users around the world, collaborating in real time, looking at green roofs, looking at through energy studies at the projects, and more detailed structural analysis on several of the buildings, and even the interiors of operating rooms on some of the projects. This is one of the results of that BIMStorm, is a 52-story tower in Los Angeles, looking at the view in Google Earth. The results of this design was output in IFCs and then imported into a desktop BIM application, in this case Revit Structure, and a team in Hawaii and Manila continued the design in the 24-hour period and completed a first version of the tower. The same model then take the data out through IFC to SketchUp to do some initial design studies. This is what the model looks like on the initial import from Excel, defining 52 stories and over 300 spaces in this tower. The same model in Revit. And in the 24-hour period, a lot of things happened. A lot of tools were used. A lot of different teams were viewing the models and the projects from their perspective and collaborating in real time to demonstrate that both through open standards exchanges and even other exchanges, if the open standard does not exist, it's possible to collaborate in ways that are unimagined in the current process of the industry. lot of tools were used, all the way from desktop BIM applications and engineering applications to Google Earth to Excel to 4D simulation in Google Earth and in other tools. And a lot of other 3D tools were also used, as well as energy simulations such as Ecotect and Green Building Studio. And Whitestone Research, for example, did an operations and maintenance cost for 20 years. Reports were generated. A model server was used to manage all the information and support collaboration between the teams. This was repeated in June in London. This is a view of all 12 teams' projects on the same site at the same time. Each team had a different approach to the projects using the model server and collaboration using IFCs. They were able to take projects, continue the design, and submit them in a 48-hour BIMstorm. And the same was repeated in Vancouver in a 90-minute session to demonstrate how the same buildings from London could be moved to Vancouver and visualized there. We look forward to everybody participating in this new BIMstorm for Alexandria and Tshwane.